Unit 10, Formative 2. Completely factor each polynomial. So whenever we're factoring, we always want to try to divide out a greatest common factor first if one exists. So on number 1, our GCF is 3 because all the coefficients are divisible by 3, and then all the terms have at least an x. So 3x is our greatest common factor, so we're going to divide that out of all of the terms. So 3 divided by 3 cancels out. X to the 4th divided by x is x to the 3rd, because remember there's an invisible 1 as the exponent on all those x's, and when you're dividing like bases, you subtract the exponents. Then 9 divided by 3 is 3. X to the 3rd divided by x is x squared, because 3 minus 1 is 2. And then in the back, negative 27 divided by 3 is negative 9. X divided by x cancels out. When we look at our leftovers, we see a trinomial, but that first term has an x to the 3rd, so we cannot factor this any further. If that first term had been an x squared, then we would look into trying to factor a basic trinomial, but since that first term is an x to the 3rd, we just stop there. On number 2, is there a GCF other than 1? No. Is it how many terms does it have? 1, 2, 3, so it's a trinomial. And the a value is an invisible 1. So that means that this is a basic trinomial. So we want to find two numbers that multiply to the number in the back, so 16. And then those same two numbers need to add up to the b value, the number in the middle, so 10. Now remember, I'm showing my work as if I don't have very good number sense, but if you can think of the two numbers that work right off the top of your head, go ahead and just write down the numbers. So I'm pretending like I don't have good number sense, so I'm just going to start with 16 divided by 1 is 16. Everything's positive, so I'm just going to add 1 plus 16 is 17. That doesn't work. Let me try 2. 16 divided by 2 is 8. 2 plus 8 is 10. So there we go, that works. So since that works, now since it's a basic trinomial, I'm ready to write my answer. X plus 2, x plus 8. Number 3, is there a GCF other than 1? No. What type of polynomial is it? It's a trinomial. It has 1, 2, 3 terms. And the a value is an invisible 1. So that means it's a basic trinomial. So I'm looking for two numbers that multiply to negative 36. Those same two numbers need to add up to negative 9. So since I'm multiplying to a negative number, one of my numbers has to be negative. Since I'm adding up to a negative number, I'm going to put the negative sign on the larger number. So 1 plus negative 36 is negative 35. That doesn't work. Let me try 2. So 36 divided by 2 is 18. Put the negative sign on the larger number. 2 plus negative 18 is negative 16. That doesn't work. Let me try 3. 36 divided by 3 is 12. Put the negative on the larger number. 3 plus negative 12 is negative 9. So that does work. So then I just get ready to write my answer. X plus 3, x minus 12. Remember, if you multiply your answer back out, you should get what you started with. So you could always check. Number 4, is there a GCF other than 1? No. How many terms do we see? 2, so it's a binomial, and it's subtraction. When you look at both of your terms, they're both perfect squares. So this is going to be the difference of two perfect squares. So you take the square root of the first term, square root of x squared is x. Take the square root of the second term, so square root of 81 is 9, and then make one positive, make one negative, and there you go. Number 5, is there a GCF other than 1? No. We have 1, 2, 3, 4 terms. So since we have 4 terms, we should try factor by grouping. So I'm going to group the first 2 terms in parentheses, and then I'm going to group the second 2 terms in parentheses. The GCF of those first 2 terms is 3x squared. So we're going to divide out a 3x squared. And then after doing the division, you're left with x minus 8. Now in the back, this is kind of a unique one. There really isn't a GCF for x minus 8, but for the sake of us having this kind of remain uniform, let's take out a 1. So like nothing really, let me put it here, nothing really changes per se. It's just that if I take out the 1, it's going to make the next step that much easier to see. So basically, those purple x minus 8s match. So we're going to divide out the purple x minus 8 out in the front as a GCF, and then we're left with the blue 3x squared plus 1. On 6, is there a GCF other than 1? No. Well, how many terms are there? 1, 2, 3, so it's a trinomial. Ooh, and the a value is not 1. So this is going to be advanced factoring. So we want to look for two numbers that multiply to whatever a times c is, and then those same two numbers should add up to the b value. So 5 times negative 16 is negative 80, and then the b value is 38. So I want to multiply to negative 80, and I want to add to 38. So 80 divided by 1 is 80. And if I'm trying to multiply to a negative number, one of those numbers has to be negative. I'm trying to add to a positive number, so that means I put the negative sign on the smaller number. So negative 1 plus 80 is 79. That does not work. Let's try 2. So 80 divided by 2 is 40. Put the negative sign on the smaller number. Negative 2 plus 40 is 38. So there we go. Now, since this is advanced factoring, we're not allowed to just jump to the answer. Instead, we're using the negative 2 and the 40 to split, let me slide that over, to split the middle x term. So I'm going to take that 38x, I'm going to split it into negative 2x and 40x. The 5x squared drags down in the front. The negative 16 drags down in the back, like so. Now we're going to want to do factor by grouping, just like we did in number 5. Let me zoom in a little bit here to make it easier for all of us. So I'm going to group the first two terms, group the second two terms. So my GCF is x. So take the x out. Leftovers would be 5x minus 2. And then in the back, my GCF is 8. So divide out an 8. Leftovers are going to be 5x minus 2. And remember, if we're doing factor by grouping correctly, our leftovers have to match, otherwise something didn't work. And then we have our leftover green x plus 8. On number 7, is there a GCF other than 1? Yes, there's a 3 there. So we're going to divide everything by 3. And then looking at our leftovers, I see 3 terms, and the number in front of the x squared is an invisible 1. So the leftovers are a basic trinomial. So I'm going to multiply to the number in the back, which is negative 8. I want to add to the b value, which is the number in front of the x. So 8 divided by 1 is 8. I'm trying to multiply to a negative number, so one of my numbers has to be negative. I'm trying to add to a positive number, so I'm going to put the negative sign on my smaller number. That didn't work. Let me try 2. So 8 divided by 2 is 4. Put the negative sign on the smaller number, and there you go. So don't forget to drag down that 3 in the back. That's a very, very, very common mistake for students, is to not remember to drag down the 3. And then remember, this x squared gets split into x and x. And then we use the negative 2 and the 4 right there, the negative 2 and the 4. So there you go. That's your final answer. On 8, is there a GCF other than 1? Yes, pretty sure that 192 is divisible by 3. So x squared minus 64. Looking at our leftovers, there are only 2 terms. They're both perfect squares, and it's subtraction. So this is the difference of 2 perfect squares. So you want to square root the first term, and then square root the second term. So square root of 64 is 8. And then just make sure you do 1 positive, 1 negative, and there you go. On 9, is there a GCF other than 1? I'm guessing everything's divisible by 4. So we're going to divide out of 4 from everything. So 3x squared plus x minus 14. And then looking at our leftovers, I see a trinomial, but the a value is not 1. So this is going to be an advanced factoring problem for the leftovers. So here's a, here's b, here's c. Remember, b is 1. There's an invisible 1 there. So we want to multiply to whatever a times c is, and then we want to add to whatever b is. So 3 times negative 14 is negative 42, and then the b value is 1. Just to save time, let me just jump to the right answer. So 6 times 7, but one of the numbers has to be negative because we're multiplying to a negative. And then I'm trying to add up to a positive 1. So I'm going to make the 6 negative. All right, so those 2 numbers are used to split this middle term here. So that'll be a negative 6x plus 7x. And then we're going to drag down the 3x squared in the front. We're going to drag down the minus 14 in the back. And then this 4 in the front is going to keep getting dragged down. But we're going to kind of just keep dragging it down and not really do anything with it besides drag it down for a little while. So let's do our factor by grouping. And again, that 4, we're just going to keep dragging down way, way, way in the front. So we're like almost forgetting about it for a while. All right, what do you have here? So 3x is our GCF of the first set of parentheses. Leftovers are x minus 2. In the back, 7 is our GCF. Leftovers better be x minus 2, otherwise we mess something up. All right, nice. Let me put a little multiplication dot here. And then those green x minus 2s are going to factor out in the front. So that 4, like I said, just keep dragging that 4 down in front. And then the green x minus 2 comes out. And you're left with the purple 3x plus 7. And typically at the end where I have that multiplication dot, let me erase that and make that just a 4. That's not typically how you write it, so just take that 4 and drag it down. And then that would be it. So this is our answer. Whew, lots of factoring. All right. Number 10, determine the inverse of the following function. So f of x or g of x or h of x, whatever the function's name is, that's your output value. That's the same as y. So I always kind of put a y over that. And then when you're doing inverses, you switch the x and the y, and then you're going to solve for y by doing order of operations backwards. So get this all by itself by doing order of operations backwards. So add 1. So x plus 1 equals 1/5 y. And then normally to undo multiplication, normally you would do division, but if I do 1/5 divided by 1/5, whenever you're dividing by a fraction, that's the same as multiplying by the reciprocal. So I'm actually just going to multiply both sides by the reciprocal, which is 5/1. Reciprocal means you just flip the number upside down. So everything over here on the right side cancels. 5 divided by 5 cancels, 1 divided by 1 cancels, and you're just left with the y. And then on the left side, that 5 in the front is supposed to be multiplied by the x and the 1. So you'll want to do 5 parentheses x plus 1. And then at the very end, if we want to be all fancy with our notation, it's f inverse x equals 5x plus 1. Honestly, I wouldn't mark it wrong if you left it y equals 5 times x plus 1, but just if you want to be fancy, that's the inverse notation right here. This is the inverse of the f function. All right, almost there. It's kind of a long formative. Number 11. The expression x minus 8 times x plus 3 is equivalent to which of the following? Use complete sentences to explain your answer. Be as detailed as possible explaining how you arrived at the answer you chose. So there's a lot of different ways to think about this. I know my brain immediately says, how about I just FOIL it out, right? How about I just multiply it out? So if I'm going to do first times first, x times x is x squared. Outside times outside, so x times 3 is 3x. Inside times inside, so negative 8 times x is negative 8x. Last times last, so negative 8 times 3 is negative 24. And then add your like terms. And there you go. So hopefully that's one of our options. Yes, option B. And then they want us to explain how we got it. So I would just say I multiplied the binomials out using the FOIL method. And honestly, that's fine. I mean, I have my work shown to back up my answer, and then I just explain that I multiplied it out. That's good enough. On 12, domain is all your x values. So we had said that all of our parabolas, unless they're in the context of a word problem, all of our domains are always negative infinity to positive infinity. So all your x values are covered eventually because this parabola keeps getting wider and wider and wider as it goes down forever and ever and ever. And remember, domain is your x's. Range is your y values. It goes in alphabetical order. X comes before y in the alphabet. D comes before R in the alphabet. For range, you want to go little to big, so bottom to top. So negative infinity, all the way up to right here, our vertex, that's our highest y value, so that's negative 4. So our range is negative infinity, comma 4, and I want to do a square bracket after the 4, because I want to include that in my answer. For the increasing and decreasing intervals, these are those ones in class where we said put negative infinity on the left, positive infinity on the right, draw in your axis of symmetry through your vertex, and then I would even go as far as to jot down the x-coordinate of your vertex, because that's the x value where your graph changes if it's increasing or decreasing. So when I look at this graph from left to right, on the left side, so over here, I'm increasing, I'm going up. So from negative infinity to 2, I am increasing. Then, as you keep looking at it from left to right, on the right side, I'm decreasing, I'm going down. So from 2 to infinity, I am decreasing, I'm going down. Number 13, transformations. So a negative sign in the front is a reflection over the x-axis. The 2/3 is your a value. So if a is in between 0 and 1, it's a vertical compression. If a is larger than 1, it's a vertical stretch. So since 2/3 is in between 0 and 1, it's a vertical compression. That +4 is inside the parentheses. So those are always our horizontal translations, and they're always the opposite of what we think they should be. So horizontal translation left 4. And then that last one, that's a vertical translation, and those are as they should be, meaning up is positive, down is negative. So vertical translation up 6.